Welcome student, chemistry by Viral sir, surface chemistry episode number 8. In this episode we will find that adsorption in solution means solution के अंदर adsorption कैसे होता है. When the solid surface is contact with the solute particle in solution, that adsorption takes place on the surface of solid, that is considered as adsorption in solution. सॉल्यूशन में एड्सॉर्प्शन कैसे होता है? व्हेन अ सॉलिड सरफेस एडेड, कुछ चारकोल और सम रिएजेंट और सम कैटलिस्ट इज एडेड इन सॉल्यूशन. In that case, what happened that some solid particles are attracted on the surface of solid particles or solid surface, and its concentration increases and it is totally covered. You will consider that is the adsorption takes place. In this three figure, you will find that in first figure that we can take aqueous solution of acetic acid CH3COOH, CH3COOH aqueous solution means acetic acid in water. That blue color line is indicate the H2O and the red dots you will find that is the solute particles of acetic acid. Now we added a particular 1 gram of charcoal in this beaker. Then what happened? After some time you will find that this some of the particle of acetic acid becomes absorbed on the surface of charcoal, and you will find that the total surface of charcoal becomes adsorbed due to this acetic acid molecule, and the concentration of acetic acid in the remaining solution, this is the part of remaining solution, becomes decreases. You can take this experiment by titration. First you take the 1 molar solution, that 1 molar solution of acetic acid, and after some times you will take some part like 10 ml of acetic acid and titrate again 1 molar NaOH with the indicator phenolphthalein or methyl orange, and you can find out its molarity. You can find that its molarity becomes decreases. Then you can understood that because of some solute particles, solute molecules of acetic acid adsorb on the surface of charcoal. That is the first thing you can conclude, that in the solution, solute particles are adsorbed on the surface of solid if we will add it in the solution. Here, one more concept you will find. Some students are asked that, sir, how can we find that interface? That you can consider that some area of the solute particles and some area of the solid particle, that total area covered separated with the imaginary line, and on this line they are contact together as well as differentiate together, and only solute particles are attracted, solvent cannot, and that's why you will find that only solute gets adsorbed on the surface, not solvent. If pure organic dye or liquid you will taken, then no adsorption phenomenon takes place. You will find in that case takes place. Some student ask that, sir, sometimes we will find that chalk stick, color chalk stick, and break it, then whole chalk stick becomes colored. So you will find that if you will take pure dye, organic dye, not the aqueous solution, and dip that chalk stick in this solution, and after sometimes you take out and break it, only solvent molecules, liquid dye with not a aqueous solution, it is a pure solvent or pure liquid, and which becomes absorbed in the chalk stick, and that you will find if you break, then whole portion becomes colored. So that thing you will find that only solute particles are attracted towards this surface and adsorption takes place, and concentration of acetic acid becomes decreases. In second example, you will find that we will take a litmus solution. You will find that this red color dots, solute molecules of litmus solution in water a homogeneous mixture solution is formed, and we will add that charcoal. Then after some time you will find that your solution becomes colorless. Your solution becomes colorless means all the solute particles of litmus solution are absorbed on the surface of charcoal. It is absorbed on the surface of charcoal, and then your solution becomes colorless. Here you will find that the litmus solute particle only attracted towards surface of charcoal and adsorption takes place. In case of third thing, we will take the solution of magnesium hydroxide MgOH twice, and it comes in contact with magnesium reagent. Magnesium reagent is a reagent which is formed with the magnesium, and you will find that from this colorless solution, the particles of MgOH twice, becomes adsorbed on the surface of magnesium reagent with the blue color, and it becomes precipitate on the surface, and you can easily find out that the blue color particles or precipitates on the surface of your magnesium reagent, and you will consider that your solution is already colorless before adding magnesium solution reagent, and after magnesium reagent, that blue color precipitates you will find on the surface of magnesium reagent. So with these three experiments, we can conclude that which factors are affecting on this type of adsorption in solution. That first we will find that the temperature. At the different temperature we will perform this experiment. We will find that the first condition, that x by m, that adsorption we will consider according to freundlich equation, inversely proportional to temperature. Means increases, that the adsorption rate and magnitude, you can say that quantity of adsorption and the rate of adsorption decreases. Second conclusion, we will find that the adsorption x by m is directly proportional to concentration of solute particle. In this litmus solution, the concentration decreases, or less concentration I will take, then after some time solution becomes colorless, only water molecules is there. All these litmus particles are adsorbed on the surface of charcoal. So you can conclude that adsorption is directly proportional to concentration of solute particle. In other way, you can say that how concentration of solute increases in solution, then adsorption takes place in more or excess proportion. The third thing you will find, that you will get x by m adsorption in solution is directly proportional to surface area. Suppose here I will take a piece of coal like this magnesium reagent, then adsorption takes place in less amount, but the surface area increases, that adsorption on the surface is also increases. So adsorption x by m is directly proportional to area of adsorbent, or area of adsorbent increases, then you concluded that adsorption increases, its rate and magnitude is also increases. The fourth conclusion you will find from this experiment, then x by m adsorption is directly proportional to nature of adsorbent and adsorbate. Means you can find that here you will find that acetic acid as adsorbate, and here litmus is adsorbate. So you can compare this both thing, adsorption becomes different. Here you will find that charcoal, and here you will find that magnesium reagent. You can find that the magnitude, the proportion of the adsorption becomes difference. So you can find out that adsorption is also directly proportional or depending on the nature of adsorbent, like a charcoal, magnesium reagent or whatever solid surface, as well as adsorbate, either solution of MgOH twice, litmus or acetic acid. So these four conclusions you will find according to this experiment. You can conclude it that how adsorption related with the temperature, how adsorption related with the concentration of solute in solution, how adsorption depending on the surface area of adsorbate, and how the adsorption is with the nature of adsorbent as well as adsorbate or adsorbent. You can consider that adsorbent has a different tendency and different capacity to attack the solute particle, and that's why the different proportion of adsorption takes place. So that is the four different factors you will find. One more experiment you will find with these things, and then you clear with the things how area is also affected. You will perform with these three beakers. You will take the same concentration of acetic acid, Suppose you will take a 1 molar solution of acetic acid, 1 molar solution of acetic acid, CH3COOH aqueous solution. Here also you will take that 1 solution of acetic acid, 1 molar solution of acetic acid. In third beaker also you will take 1 molar solution of acetic acid. Then you find a different area of adsorbent, You will find here that here the small area, piece of coal you will take. Here increase the area of your coal like this, and here you take the powder form of charcoal, Then you will find that on this surface some solute particles of acetic acid becomes adsorbed. On this surface also it becomes adsorbed. You will consider like this, and on this surface some molecules of acetic acid becomes adsorbed. How you will determine this? Then in the surface area increases, that adsorption increases. So you will find out after some times the remaining solution you will take out from this 10 ml solution. Initial concentration of 1 molar, and then after you will find that you will add 1 gram of coal with the small piece, 1 gram of the small piece, and after some times, after 10 minutes or after 15 minutes, the remaining solution you will take 10 ml and titrate against NaOH, 1 molar solution on NaOH, and find out its molarity. It is decreased up to X molar. It is decreased up to X molar. Now same 1 gram higher surface area piece of coal is taken, and after the same time you will titrate with the 1 molar solution, and you will find with the 10 ml solution it is decreased up to Y molar. In that charcoal you will consider the powder form and more surface area. After 10 minutes its 10 ml solution you will titrate again 1 molar of NaOH. You will get the decreasing in concentration is Z, and the XYZ relationship you will find that the X is higher concentration than Y is the higher in concentration than X. then you conclude that the concentration of remaining solution of acetic acid in third beaker, that is in very less, because more adsorption takes place, more molecule of acetic acid up on the surface, and that's why its concentration becomes very less. And the high concentration you will find in the first beaker because of the small area, the less number of molecules are adsorbed on the surface of a piece of coal, and that's why concentration of X is decreases in less proportion, and concentration of the last beaker decreases in the highest proportion. So you can understood with this experiment then how the surface area of adsorbate is affected on adsorption. Second, we will consider with the same thing, which is the temperature. You will find that temperature increases, then adsorption rate also decreases. The same molar solution we will take, and same type of piece of coal, 1 gram charcoal, and same surface area having 1 gram charcoal we will take, and the different temperature we will take. Suppose here 273 Kelvin, here 244 Kelvin, 193 Kelvin temperature is taken. You will find that here the maximum adsorption takes place. Maximum adsorption and instantly takes place. After 10 minutes, you find it is decreases up to X level, it is decreases up to Y level, and it is decreases up to Z level, and you will find that higher concentration of X greater than Y greater than Z. So you will consider that in beaker 3, lower temperature, maximum adsorption takes place, and the higher temperature in beaker 1, the lowest concentration we will find that adsorption takes place in less amount, and you will consider that X by M inversely proportional to temperature. The third thing you will find that nature we will discuss, that if magnesium reagent and charcoal, that is the different proportion of adsorption takes place. So that is also depending on the different solute particles, that is the nature of adsorbate, and nature of adsorbent, that is the different magnesium reagent as well as charcoal. One more thing you will find that you will consider that the concentration difference you will find, here you will take 1 molar solution, here you will take 2 molar solution, and here you will take 3 molar solution, and the same surface area of charcoal you will find with the 1 gram with per unit volume 1 gram per unit volume, means surface area and mass of adsorbate molecule becomes same, and also temperature is same, that in solution you find out the adsorbent rate and adsorption proportion are, you will find in different way. You will find that in more concentration, in higher concentration, that higher adsorption takes place, and you will find the very less concentration of remaining solution. Y has more concentration because due to adsorption more than less than Z but more than X you will find here, and the very less adsorption you will find in the lower concentrated solution, and that is considered as X. So you will find that X is the very very higher concentration solution, very higher concentrated solution, because very less adsorption takes place, and that's why its concentration is decreased up to low level. Here Y is the middle one, and Z, concentration of Z is very low because more proportion of adsorption takes place due to higher concentration of solute molecules. So these 4 different relationships you can understood with the help of these 4 different example with the things, and we can implement just this adsorption according to freundlich equation, we will find that we can apply the freundlich, that x by m proportional to, instead of pressure he will find the concentration of solute molecule C, and that's why you will consider that adsorption x by m is directly proportional to concentration raised to 1 upon n. Then you will put the value of constant of proportionality, that k into c raised to 1 upon n. Finally you will take both of side logarithm. You will find that log x equal to log k plus 1 upon log c. You can adjust the step, that log x by m is equal to 1 upon n log c plus log k. You will compare this equation, that y is equal to mx plus c. Y is equal to mx plus c. Here on the y-axis you will take the log x by m, and on the x-axis you will take that log c. Then you plot a graph. You can understood with the things we will draw here, and that you can understood. Here you can take log x by m, and here that log p, it should be straight line, and you will get that a slope from this straight line, that a b c, then slope is equal to ab by bc, and that is the 1 upon n according to tangent straight line equation. You will compare that, and you can extend this straight line up to y-axis, that intercept obtained on y-axis, that given the value of log k. Here one more thing, still we discuss that if this graph becomes straight line, positive slope containing straight line, then only you consider that your adsorption becomes true or verified or valid. If it not become a straight line, you cannot implement this adsorption equation or freundlich adsorption equation for this type of solution. So with the help of this equation you can understood that value of n and value of k you can obtain, and its value is changed with the change of temperature, with the change of pressure, with the change of nature of adsorbate and adsorption. Consider that the value of Kn is not constant. That is the one of the biggest limitation of this equation, and that's why this equation is empirical only. It is only the experimental base, no theoretical proof is there, and that's why some other equation is also proposed, that is called Langmuir adsorption equation, but that is not in your syllabus. But for NEET Z point of view, when we meet face to face, then we will discuss its equation. I will propose you that x by m, that step according to sorry, I will write here, and you can see here, according to Langmuir equation, that adsorption x by m is equal to AP upon 1 plus BP. Here P is pressure, A and B are considered as constant of Langmuir, which is dependent on the temperature but does not depend on other nature like this. So it is more effective than freundlich equation, and it is implemented in two different ways, that at high pressure and low pressure. The different form of this equation, you will find that at high pressure value of BP is very high as compared to 1, then you can take x by m is equal to AP upon BP, because 1 is a negligible, PP cancel. Finally you will find that x by m is equal to A by B, and A by B becomes constant. So it is proved that at higher pressure up to certain level, on this pressure we will consider that is the high pressure it becomes constant, and low pressure you can neglect value of B product with P, then your equation becomes x by m equal to AP upon 1, then x by m is equal to A into P, means x by m directly proportional to P. For solution, you can consider instead of P, you will take C here, so AC upon BC. In that same thing, that you will find the K only, and here instead of P, you can implement C. C is the concentration. The concentration of solute is affected. How affected? On the adsorption or rate of adsorption or proportion of adsorption, that you can understood. So up to here you can understood how different factors are affecting on the adsorption in solution. Now in next episode we will find the different applications of this adsorption, and you can read up to here and write in your notebook as a short note that first thing, adsorption in solution explain with the freundlich equation. Second, that the different factors affecting on adsorption. Third question you can write, then give the adsorption, freundlich adsorption isotherm, and explain its terms. So we will finish our episode up to here. We will meet next episode with the application of adsorption. Okay, good day.